function is concave up, in that interval the derivative of that function will be decreasing. Alright. In an interval where the function increases, its derivative is positive. Now, what does that mean? If a function is increasing, remember derivative is a rate of change. If a function is increasing, the change will keep on increasing. That means the rate of change will be positive. Because you see, change is final value minus the initial value divided by the change in x. So if the final value is greater than the initial value, that change will be always positive. That means in an interval where the function is increasing, the derivative is positive. Does it make any sense to you? Well, look at that. If the function is increasing, then the derivative f prime x is positive. If f of x is increasing, its derivative will be constant. In other words, the slope of this line will be a positive value. F prime x is constant and positive in this case. That's right. In an interval where the function decreases, let's take the case of this function graph. This is the case of a function that is decreasing. For this x value, the function value is a large one. As x increases, the function decreases. So we call this a decreasing function. And the slope of such a line is negative. So in an interval where the function decreases, its derivative is negative. Very important relation there. So how many properties we talked about so far? Let's summarize that. In an interval where the function is increasing, its derivative is positive. In an interval where the function is decreasing, its derivative is negative. In an interval where the graph of a function is concave down, the derivative will progressively decrease. In an interval where the graph of a function is concave up, the derivative will progressively increase. That's right. Okay. Now, what's the graph of f prime x in these cases? At points where the function has a maximum or a minimum, that's the next property. At points where the function has a maximum or a minimum, look at that. If a function increases, reaches the maximum, and then turns back. Now, what is the derivative at the turning point? At the turning point, the tangent line will be horizontal. That means at a point where the function has a maximum, see something like this, at the maximum point, the tangent line will be horizontal. Similarly, at a minimum point, the tangent line will be horizontal. Like here, we have a function has a maximum value here, the tangent line is horizontal, the slope of the tangent line is 0. At points where the function has a maximum or minimum, the tangent line is horizontal and the derivative is 0. So, many important properties of derivative. In the graph shown here, we said f prime of 2 equal to 0. What does that mean? The derivative of this function at x equal to 2 equal to 0. That's right. Now, look at this figure. The figure shows the graph of a function f of x. Use the properties of the derivative to sketch the graph of its derivative. In other words, we need to draw the graph of its derivative using the properties of the derivative. Now, what are the properties that we're going to use? I want you to watch and listen carefully and try to understand how the properties of the derivative is used to draw or sketch the graph of a derivative if the graph of a function is given. First of all, what I will do is, I will say the function has a maximum value here. and what is the value of the derivative at the maximum value. The tangent line there will be horizontal and the derivative will be 0 there. That means at x equal to 2, the derivative is 0. That means when you draw the graph of the derivative, it will cut the x-axis at x equal to 2. In other words, this is the x-intercept of the graph of its derivative. You see, one important information. Then, if you notice here, the graph is concave down. The graph is concave down in its entire interval. If the graph is concave down, its derivative will be continuously decreasing. That means the derivative will start at a point somewhere here and will decrease. You see that? That's right. Another thing, in an interval where the function is increasing, the derivative is positive. Look at that. This function is increasing from negative infinity to 2. Up to here, the function is increasing. That means up to here, the graph of the derivative must be above the x-axis because it is positive. The positive part of the graph must be above the x-axis. So, since the function is increasing from negative infinity to 2, the derivative of the function in that interval will be positive and appear above the x-axis. That means the graph of the derivative is going to cut at x equal to 2, and up to here the graph will be above the x-axis, and from 2 to infinity the function is decreasing, means the derivative is negative. The derivative is negative means its graph will appear below the x-axis. That means you can draw the graph very easily now. It's a straight line coming like that, positive above the x-axis, cut the x-axis there and go that way. Let's put it down. F of 2 is a maximum. F of 2 is a maximum means f prime of 2 equals 0. The derivative at that point is 0. The graph of the derivative therefore has an x-intercept 2, 0. The derivative graph will cut the x-axis at x equal to 2. Why? Because the value of the derivative at x equal to 2 is 0. Means its graph must cut the x-axis at that point. On the interval negative infinity to 2, f of x is increasing and concave down. Increasing means the derivative must be positive. Concave down means the derivative must be decreasing. So the derivative will start at a high value there, it will decrease. So the derivative f prime x is positive and decreasing on this interval. So f prime x means the derivative will start with a large positive value and then decreases and reaches 0 at x equal to 2. There comes the graph. There you go. So the derivative will start at a large positive value, decreases and reaches 0 at x equal to 2. Alright. F prime x is positive and decreasing in this interval. How about on the interval 2 to infinity? On the interval 2 to infinity, the function is decreasing. That means the derivative will be negative and decreasing because it is concave down. So f of x is decreasing and concave down. Therefore, the derivative is negative and decreasing. The graph of the derivative must appear below the x-axis and it must decrease continuously. Is that right? There you go. The graph must be like that. Well, it must be actually a straight line going right through. Now look at the way the information of the properties of derivatives helped us to draw the graph of the derivative when the graph of the function is given to us. Alright? I want you to practice this. It's a very important skill. So here the derivative is negative and decreasing.